Hello, everyone. Welcome to my presentation of Australian house price prediction data exploration. This project is here to fulfill the Capstone project completion of the Advanced Data Scientist project by Coursera. Here, in the first step, we find the data set source from the Kaggle website. According to their API link reference, we were able to download the library and import the library and download the dataset from this link you see here. And of course, we need to register for the account for the data download. For such, by checking the downloaded document, we have two CSV tables. By concatenating them, we got the frame as attached. We have found that for the first part of the frame, actually we have a lot of data missing. For example, the bedroom numbers, bathroom numbers, and the land size. Everything behind that for the details of the property has been missing. But for the second part of the data table, we have like more information, more details, except something missing here. So let's see what other information we have here. We have the suburb of the property, address, which will be used as the primary key of the data, and the rooms. I think they basically they are same number of the bedrooms. And type refers to the what kind of property. Say they are houses, they are townhouses, and the units of apartment. The price, of course, that's the target we are going to predict in this model. Methods refers to the, according to the website, it's the how it's being sold. For example, it's sold before auction or sold on auction or after auction, which indirectly reflects the popularity of the property. Seller group, which is the agent. We also have the sold data, like by month. Postcode, which is in a funny data format. I think it's a float. We need to convert it into a string because that's definitely not numerical data. That's categorical data. Region name and some other location information. Distance, which refers to the distance from city to the suburb to the property. Actually, I think it's just to the suburb the property was in kilometers. Council area, of course, that's influence the price of the house. Bedroom, bathroom, car lots, land size, building area, year has been built. But it doesn't include any information whether it's renovated or not, whether it has like a very good view or not, whether it's on the very popular street or whatever, the neighborhood, the venue, restaurants such as train stations, that kind of information, which also definitely will influence the price a lot. We also have some extra latitude and longitude information. I'm not sure which part will be finally used, but we will see after a little bit data visualization in the second step. Here we have the suburb in a word cloud. Basically, we see the larger words mean the more sales in that particular suburb. There are some popular words like Bentley East, Richmond, Glen Iris, and some other like Glen Waverley in like smaller taxes with and we have the sales by number in different regions. Metropolitan, which means where the train routes covered and they're like further rural areas in Victoria have much less sales, which just means the density of that property is not that high as in the city area. Here, the sales by city councils, we can see like a few lot of sales happening in the these city council, but they're like much fewer in the shire council areas, which is rural. More information from the data set. We have rooms which have like a same number of the bedrooms. They are, I think they are identical, just recorded in a different way and imported as duplicates. A lot of them are 3, 4, 2 bedrooms. Some are 4 bedroom, but there are very few above 6 bedroom. But there's like some scattered data for a lot of bedroom, which may be a mansion in the city area or a villa in the countryside. House type, of course, there are more houses than the unit, and the townhouses can combine. Bathroom, most of houses have like 1 or 2 bathrooms, but there are 3 bathrooms, 4 bathrooms as well. Sale methods, a lot of it just been listed as sold. Yeah, but about other types of how the property has been sold. Cost basis, that might be very useful for the units and the apartment, but might not be that useful to the full block of land of houses, because usually you have extra space for the car space. I don't believe it has been recorded very accurately to represent the condition of the car space, for example. We have the seller group accounts. Here are some big brands, Barry, Jellies, Nielsen, which are 3 biggest group of the agents. All right, and then we see what types of the data are they? They are, for example, here some issues with the date or like types, and the postcode, they shouldn't be in floats. As I said, they are categorical data. They are not the number of the postcode doesn't mean anything. And bedroom, bathroom, actually, we, after looking at the data, we know they basically integers. They are not floats. Yeah, definitely it's an integer. After, as mentioned, we have a lot of known values. We have so limited information. So without the bathroom number, bedroom number, or land size, things like that, we cannot accurately predict a price just based on the location information, basically here. That's why we have to drop this data with any of the known values in this syntax. After counting how many unique values there are, we found there are 8,887 unique data. Or actually, it's 8,764 unique data. These are the known values, but there are some addresses actually duplicating themselves, because they might be duplicated in registration, or they have been sold multiple times during the 2 years we are looking at. We have able to convert those data types into, for example, room to integer numbers, and the postcode to reasonable string values. Hence, we have like a more cleaner and reasonable data types. By a quick glance of what we have at the moment, we don't have known values. We have them all in the desired data format, for it at least to be clean at this stage. And we also did some rename. to make better sense. For example, the seller G, we might get like agent. And we have distance, which turned into distance to CBD. As mentioned, we do have some data types which are in categorical data. In order to put them into machine learning model, we need them to be numerical. Here we want to perform some one-hot encoding for some very important data types, like what type of the house is it? Because we know at the same location, the price for the house and the townhouse will vary a lot because the block of land, the size of the building, and the extra like gardens, things like that are not included here, and the potential to value appreciation. Hence, we further drop the duplicate information such as rooms and bedrooms. Basically, they are same information. Postcode. Oh yeah, we move the postcode to the suburb because one postcode related to one suburb. They are same address information. We were able to make some more counts of the features. We're starting to change compared to the before. We have some cardinality checks. We see some information such as the suburb, they were 315, but for the region, there are 8 regions, and their bedroom distribution, they are all different at different sizes. If they have like too much variation, and we will consider to bin them into categories. So the machine in the modeling processes, they will be more efficient in terms of the computational power usage. Here are some further summary statistics. And we perform the correlation calculation here. As we see, the price is negatively correlated to the number of properties in suburb, negatively correlated to the distance to CBD, which is making a lot of sense because the further away from CBD, the house price will drop. Bedroom size, of course, and bathroom size, they are very much positively correlated. Interestingly, the land size, according to our knowledge, it should be very positively related, but it's not appeared here, which I think is because of we haven't separated the house from the unit and apartment. For the unit, townhouse, and apartment, we actually do not have a land size, a large land size, because it's shared, built on a shared land. However, the building size is more relevant in that kind of situation, which is represented here. And the more recent the house is being built, the price is tend to be higher, which is very reasonable. However, we haven't included the renovation, things like that here. And we don't know the condition of the house either. In some data sets, they do have like a rating, or what the percentage of the house of in terms of the renovation qualities, but it's not appearing here. But we can do nothing about it. And longitude and latitude, interestingly, is quite significantly related compared to some other features. To me, it means like because in Melbourne City, in the west part, they are more like industrial areas, and in the southeast, they're like more residential areas, and there are also new development sites in the north, in the west, southwest, and in the far southeast. So to me, it means like the absolutely location of the property is somehow very related to the city layout or city development plan. And of course, in terms, it's also related to the price of the property itself. We'll see how we're going to use it. Right. Yeah, here more, yeah, just more correlation. Here we have one line, so we can check out what kind of data we have. Another correlation table. Here, start from here, we start to do some one-hot encoding. Basically, we have a lot of things in characteristical data types, but according to the table above, we figured out the type of the property is very important. As we see, where we see somewhere. Yeah, as to our common sense, different property types will very largely decide the final price of the property. Hence, we want to make this numerical data for the machine learning process. Also, the relative location of the property in different suburbs could be another important factor. Whether it will be in a very good suburb, we have like a better education, better venues, or restaurants and the shopping centers. In return, it will influence the price a lot. So we picked up 2 of these data. Actually, I have tried other data, but due to the limitation of our dataset size, we actually cannot see like obviously a year or month pattern in that short time frame within 1 or 2 years time. Because each property is unique. Each property has like a different condition. So it's pretty hard without further information such as ratings of the condition, ratings of the scenery, ratings of the street, ratings of the particular neighborhood, things like that. Hence, we have all the columns sorted out. Here we go. We also drop some duplicated address here, but what I want to show you is we have these important information sorted out. It's price, the column names are property in the suburb, which is numerical, might be useful, distance to city, bedroom, bathroom, car, land size, building area, year it's been built, latitude, longitude, we'll see whether it's will helpful or not, and 315 postcodes. You see some of them actually influence the price a lot more than others. So we will see if it's useful or not. Importantly, we do have like a house, townhouse, and the unit. As you can see, if you have house, the price will be positively correlated. Townhouse, not that much. Unit, definitely not very good for the price. There will be exceptions, but that's in a general trend. From here, we have the model definition, model training, and the model evaluation. First, we're gonna employ the we pass the data frame into the target, which is the price column, and the data column. Data includes everything besides except the price column. And we do the linear regression model. We have done train split about 8% to 20%. Fit the model, and we get the mean squared error and scheduled mean squared error about 2.48. And after the model build, we pick up one particular random house, which is number 30 Johnson Street, to double check how much offset between our prediction and the real data. We can see real price of this property is 1,415,000. That's actual price. And here we have the predicted value about 1,561, which is pretty close, right? So we divided the prediction value by the actual value. We got the 1.03, which is only 3% offset. That's good. And for the second model, we introduced the tensor and the Keras in the notebook. We introduced the sequential model from the Keras models. Same, we split the data to 80% as the trained data and 20% as the test data. We have the parameter dimension is 328. The build the batch size 20, epochs 200. I tried 100, 200, but they're not significant difference. But yeah, just do the 200. We also use the same mean squared error as the loss matrix. And here we go. We start the model, and during the machine learning process, the machine was able to bring down the loss from this number to only about this number, which give us a scaled mean square error about 2.9 on average. Again, pick up a random house, which is 3/388 on Dandenong Road. Let's see if it's a house or something. Yeah, it's a unit. All right, it's a unit, and the actual price is 550,000, and the predict price is 640,000. Well, there's like a 16% greater in the prediction value than the actual price. Again, said the unit price, and doesn't matter unit price, tiny house or the house price, it's depend a lot on the condition, the layout, the orientation of the bedroom, the bathroom, the condition, the the everything inside, outside, and also neighborhood and the venues around it, whether it's a train station or whether there's like a criminal rates in the local area, things like that. A lot of factors could influence the price largely. Also, I put it in a lot of random houses to check the prediction. They all range between like a few percent to like 20-30% in value up and down. It's not perfect, but it gives a roughly range, which is pretty good. And last, we have plotted the modeling process, plotted the loss against the epochs. As we see, we bring down the losses from 3.1 to about 2.7 in this case. Here we go. Thanks for your attention.